Hello students, I am Shrikala, faculty from the Department of Mechanical Engineering, Global Academy of Technology. Today in this lecture, we are going to solve some more numericals on fins. So in this problem, there is a turbine blade which is of length 60 mm, made up of stainless steel and having the thermal conductivity of 29 watt per meter degree centigrade. The length of the fin is 60 mm. 500 mm square cross sectional area. That means the area at the cross section is 500 mm square. And what is the perimeter or the surface length or the perimeter is 120 mm. That is 0.12 meter. The temperature of the root of the blade is 480 degrees centigrade. That means if we consider this as a blade, the base temperature is 480 degrees centigrade and it is exposed to products of combustion passing through the turbine at 820 degrees centigrade. That means, please listen carefully here. The atmospheric temperature is 820 degrees centigrade. That means surrounding temperature is 800 degrees centigrade. It is quite higher than the base temperature. One thing we need to make sure here that the heat is not transferring from the fin to the atmosphere. Here the heat transfer is occurring from the atmosphere to the fin. So now, if the film coefficient between the blade and the combustion gases is 320 watt per meters square degree centigrade, that means H is 320, determine the temperature at the middle of the blade. That means if the blade length is 60 mm, so temperature at the middle of the blade. That means what will be the X? X will be equal to L by 2. So now, first thing what we need to do, we need to check whether this is a long fin or a short fin. For that, we need to find out the value of m. So m equals square root of hp by ka and all these values are directly given. So the m value is 51.46. Now, what is m into L? We'll get the value of 3.087. So that means it which is less than 5. So less than 5 means it is a short fin. So now, since he has not given anything and the temperature, atmosphere temperature is very high, we'll consider as a short fin with losing heat due to convection at the tip. So for that, we need the value H by Km. So obtain the value of H by Km. So here, temperature at the middle of the blade. So this is the expression for the short fin uninsulated or the losing heat at the tip. So at x is equal to L by 2. So I have taken m into L minus x. L is nothing but same L, the length of the fin. X is equal to L by 2. So L minus x, L by 2. So we'll get it as, this complete expression we'll get as 1.5435. So after substituting, we get the temperature at L by 2. That means at the middle of the fin to be 745 degrees centigrade. Then we need to find out the heat flow. So Q equals, this is the expression for the short fin losing heat at the tip. So K ACS M into TB minus T infinity multiplied by tan hyperbolic ml plus h by km divided by 1 plus h by km tan hyperbolic ml. Now substitute the values. Finally, we'll get the value of Q negative. Why the value of Q is negative? Here, the heat loss is occurring from the heat is transferring from the atmosphere to the fin. That's why it is we get the value negative value. Now, coming to the next problem. See, in this problem, they say the thin fins of brass. So these are the brass fins, let us assume, whose K is 75 watt per meter Kelvin, are welded longitudinally on a 5 centimeter diameter brass cylinder. So consider this as a center brass cylinder and its diameter is 5 centimeters. just a sketch is given here, 5 centimeters, which stands vertically. That means the cylinder is vertical, surrounded by the air at 20 degrees centigrade. That means atmospheric air is 20 degrees centigrade. The heat transfer coefficient from the metal surface to the air is 17 watt per meter square Kelvin. That means H is 17 watt per meter square Kelvin. If 16 uniformly spaced fins are used, let us assume these are 16 fins. Since I didn't get the 16 fin picture, I have kept the whatever is the picture available. So assume there are these fins are 16 fins used each 0.8 mm thick. So what is the thickness of each fin? That is, thickness of each fin is 0.5 mm, extending 1.2 centimeter from the cylinder. Please make sure these words, so that should be the length of the, that you have to consider as a length, extending 1.2 centimeter from the cylinder. That means from the cylinder till the tip, this length is 1.2 centimeter. What is the rate of the heat transfer from the cylinder per meter length to the air when the cylinder surface is maintained at 150 degrees centigrade? What do you mean by per meter length? That means this length of the cylinder is 1 meter. It is same as the breadth of the fin. See, please make sure the length, the breadth and the thickness of the fins are taken accurately. Otherwise, the problem completely goes wrong. Now, so here we are using thin fins. So I'm assuming short fin with insulated tip. That you can check by using the value of M into L. Get the value of M into L, and if it is less than 5, it will be short fin. Since the fins thickness are very less, we are assuming that convection from the fin tip is very small and we are neglecting it. Now, to get that, we need to find out the perimeter. So, perimeter means here at the tip, what is the perimeter? So, 2 times the breadth plus delta. That is nothing but the length of the fin tip. Total length, that is this thickness plus breadth plus thickness plus breadth. So, 2 times b plus delta will get 2, and area is equal to breadth into delta. So breadth is this 1 meter multiplied by delta is the thickness of the fin. So you'll get the area. Substituting, we'll get the value of m. Now check whether it's a short fin or a long fin. So multiply by L. If this value is less than 5, it is a short fin. Now, to find the heat transfer from the fin, so Q of the fin is given by this formula, root of HPKA into Tp minus T infinity tan HML, and that value is obtained. Now, this is for a single fin. So, but in the problem, they have given there are 16 fins are used. So, 16 fins means multiply by 16, you will get the sum amount. Now, one thing we need to come to know here is from the body, the heat transfer occurs in 2 ways. One is through the fin and directly from the body through the space which is available between the fins. So, heat transfer from the body will be equal to sum of the heat transfer from the fins plus sum of the plus heat transfer from the space between the fins. So, how do you obtain the heat transfer from the unfinned surface? That is, space between the fins is written as unfinned surface. It is given by the total pi into d, that is total cylindrical circumference, multiplied by this breadth. So breadth means this cylindrical circumference multiplied by breadth gives the perimeter of this base body. That minus this breadth into thickness, right? So minus breadth into thickness of 16 fins. So the multiply, this is HA into delta T. Delta T is TB because that base temperature, it will be the temperature will be the base temperature minus atmospheric temperature. This gives the heat lost from the unfinned surface. So what are the total heat loss will be? Heat loss due to the fin plus heat loss from the unfinned surface, the total heat loss will be 1145 watts. Now, let's go to the next problem. So, this was asked in January 2018. A very long rod of 25 mm. So here, just by this word, we can assume that we have to assume it as a long rod. Okay, that means rod of infinite length. And that rod is 25 mm in diameter, has one end maintained at 100 degrees centigrade. That means one end of the rod is, let us assume that as a base temperature is TB as 100 degrees centigrade. The surface of the rod is exposed to ambient air at 25 degrees centigrade. That means T infinity is 25 degrees centigrade with convection coefficient of 10 watt per meter square Kelvin. That means the value of H is 10. What are the heat losses from the rods constructed of pure copper with K 398? That means K of the copper is 398 and stainless steel with K as 14. That means here they are using two rods. One is copper rod, another one is the stainless steel rod. Now we need to find out, or we need to estimate how long the rods must be to be considered infinite. How do you consider the length of the rod is infinite? This can be considered that if the end of the rod, if you consider a rod, if the end, at the end of the rod, if that temperature is same as the atmospheric temperature, that means the rod is of infinite length. That means that it is not losing any heat from the tip of the rod. So to do that, now let's go through this. First step is we need to find the perimeter of the rod. So since both the rods of same diameter, so the P is same for both the cases. Then area pi d square by 4 is also same for both the cases. Now we need to find out the Q for an infinite length rod. So for a copper rod, Q of infinite length, the formula is square root of HPKA into TB minus T infinity. We get the value of Q. Now, again for the infinite length rod of the rod QS, that means for a steel, square root of HPKA into TB minus T infinity. So only difference between these two, Q, that is the rate of heat transfer through the copper and the steel, is with K. K value is different for copper and K value is different for steel. So for a steel, we get the heat dissipation as 5.51 watts. Now, what we need to find out, we need to find out how long the length of the rod to be to consider as an infinite length. So what we are doing is here, we are equating the heat transfer from an infinite length rod to from a short fin with insulated tape. Short fin with insulated tape means since here we can get the value of L. Otherwise, the L value is not obtained here. So we are equating these two cases for both copper as well as the steel. Now for the copper again, for both the cases, if we equate these two, so all gets cancelled. The root of HPKA and TB minus infinity gets cancelled. We get that tan hyperbolic ml should be equal to 1. That means for if you consider as 1, it's you will get infinity or some indeterminate value. So consider it as 0.99. Tan IHML consider as 0.99. So if we consider 0.99, see is given here, it is considered as 0.99. So for the copper rod, what is the value? Since M value varies for both copper and the steel because of the K, conductivity K value, difference in the conductivity K value. So M for the copper rod is 2.005, then M into L should be equal to, right, tan inverse hyperbolic 0.99. So we'll get the value of some value and from this get the value of L since M is known. So what should be the length of the copper rod? Length of the copper rod should be 1.32 meters to become as then infinite. That means minimum length should be 1.32 meters to consider as an infinite length. Similarly, for a steel rod, get the value of M and get the value of length. So steel rod, the length should be 0.247 meters. That means with 0.247 meters, the length at the tip becomes almost insulated. That's why we use shorter length steel rods as for the cooking purpose, as a ladle in the cooking purpose, or a serving spoon, because the length will be very small compared to the copper rod. This is because conductivity of the copper is very high compared to the steel. Now, let's get into the next problem. Here, we need to determine the amount of heat transferred through an iron fin of thickness 5 mm. So, consider it as a rectangular fin. So, its thickness is given as, this thickness is given as 5 mm, height 50 mm. Please make sure, I have underlined here, many of you make mistake, height means thickness. Please don't consider that. Height means it is the length of the fin. Many of the times students make mistake in taking this height as thickness. Please don't take height as thickness. Here the height is nothing but the length of the fin. Width, when width is given, width means that is the breadth, and thickness they have directly given as 5 mm. So always this should be the length of the fin. Now, you need to determine the heat transfer Q from the fin. Also determine the temperature of the center of the fin, that means temperature at the center of the fin as well as temperature at the tip of the fin, assuming the atmospheric temperature of 28 degrees. So assume the temperature of the atmospheric temperature as 28 degrees. For that, take K value, H value, and fin base temperature, that is TB, as 108 degrees centigrade. So again here we are assuming as a short fin, so you can check it out. M into L, if it is less than 5, it is a short fin, otherwise considered as a long fin. Now we are assuming fin losing heat at the tip. See thickness is almost 5 mm. So I am just assuming thickness, the short fin with losing heat at the tip. So you can also calculate short fin with insulated surface. There will be not much difference in the Q value. Now get the value of A is equal to B. But to get the accurate value, if you use the short fin with losing heat at the tip, then we'll get the accurate value. Okay, now coming to the area is equal to breadth into thickness, get the area value, perimeter, length of the four sides at the tip, so perimeter, and M is equal to root of HP by KA, you will get 8.97. So you can check again this M into L, you will get less than 5. So we will considering as a short fin. Now, short fin losing heat at the tip. This is the rate of heat transfer for short fin losing heat at the tip. So Q will be equal to KAM into TB minus T infinity, and then this expression. So if you substitute the values for this expression, you will get the rate of heat transfer through the fin. Now, we are going to obtain the temperature difference at the tip of the fin, or for this, we need to use the expression for the temperature distribution expression for the short fin losing heat at the tip. And this is the expression. And we know what is theta. Theta is nothing but T minus T infinity. T is the, we can, T is the temperature of the fin at the specified location. So here in the problem they have asked, one is at the tip of the fin, other one is at the center of the fin. So if we consider at the tip of the fin, then theta will be equal to, theta is nothing but T minus T infinity. So theta will be equal to, I'm just taking the denominator part TB minus T infinity into the numerator on the RHS, TB minus T infinity into, listen here, see here, cos hyperbolic m into L minus x. So what is the x value? X is nothing but, at the tip of the fin, x is nothing but L. So L minus x is 0. So if you just consider, so it is cos 0. Cos 0 is 1. Here sine hyperbolic 0 is 0. So I am substituting 0. So if you substitute for all these, and then you'll get the expression for the, or you'll get the value for the theta. What is theta? Theta is nothing but the temperature difference between the fin and the atmospheric temperature. Since we are taking at the tip, that means temperature difference between the tip and the fin is 71.9 degrees centigrade. So what is the temperature at the tip of the fin? It is, we are just taking on the other side, we'll get the T value as 100 degree centigrade. Now see here, only for the tip of the fin temperature is calculated. Now please you use the same procedure to get the temperature at the center of the fin. That means at L is equal to, or X is equal to L by 2. So here in the same expression, instead of X, you substitute as L by 2 and obtain the value, or obtain the temperature at the center of the fin. Now, the last problem is, see, it's one of the typical problem. Many times this problem is asked in the examination. So, a motor body is 360 mm in diameter. So, you have a motor body 360 mm in diameter, and so what is the bed? It is given as 240 mm long. That means this, the fin is 240 mm long. That means 0.24 meters. Its surface temperature should not exceed 55 degrees. That means the motor body surface temperature, not the fin surface temperature. So motor body surface temperature means it is the TB, or the base temperature, it is 55 degrees centigrade. When dissipating 340 watts, that means the complete motor body is dissipating 340 watts. The longitudinal fins of 15 mm thickness. So first thing you write it down, thickness of the fin as 15 mm and 40 mm height are used. Again, see, listen here, it is height. Wherever you get it as height, you consider as the length of the fin. That is the fin, with the length of the fin which is extruding from the body. See, these are the, see, you can see the horizontal fins which are extrude. This is the length of the fin which is extruding from the body. It is nothing but the height of the fin. So since the motor body is now again, okay, convection coefficient is 40 watt per meter square degree centigrade. Determine the number of fins used. So you need to find out how many number of fins to be used in order to dissipate 340 watts. Now, assuming the atmospheric temperature is 30 degree, so atmospheric temperature is 30 degree for a finite fin. They have already given as a finite fin, so that means a short fin. You can even check it whether it is a short fin or a long fin using the expression ML. If it is less than 5, it is short fin. If it is more than 5, it is a long fin. Now consider thermal conductivity of 45. So K is 45. So now I'm considering again as a fin of finite length losing heat at the tip. Why I am using is because we'll get the accurate expression, accurate answer. Even though the expression is of lengthy, we'll get the accurate answer. Now area, this breadth into thickness. So breadth is nothing but your, this motor body long. That is your breadth. So what is this? Height is nothing but the length of the body. Okay, so now what is the perimeter? 2 times the breadth into delta is the perimeter. So m value, substitute, get the value of m value, find out what is m into L. So m into L is 0.45. So it is far less than 5. So it is a short length, short fin. Now substitute in the Q. So whatever the Q we get is the rate of heat transfer from a single fin. So how much heat is getting transferred or dissipated by a single fin? It is 22 watts. But we need 340 watts to be dissipated. So how do you find that? We need to find how many number of fins to be used. So number of fins required is equal to Q total divided by Q per fin. So Q total, what is amount of heat? 340 divided by per fin is 22. So we'll get somewhere around 16 fins. So at least minimum number of 16 fins to be used in order to dissipate 340 watts. Thank you.